round up what factorizing is about, do a couple of examples and different types of factorizing, how you can recognize factorizing in things that might be hidden. That's what math does. Math teaches you a concept and then it hides it a little bit to see if you have the brains to see, to pick out the pattern. Okay, so factorizing in its simplest form is a way of saying, for example, 12 is equal to, how can we factorize 12? Let me ask you guys, how can we factorize 12? If you understand what factorizing is, factorize 12 for me.
It's like 1, 2, 3.
Okay, so by factorizing 12, you are saying it's 1, 2, 3, 4, 6, and 12. Okay. So this is 12 is equal to, is 12 equal to all of these? Remember, with math, you have to speak the mathematical truth.
And it's like 1 times 12, and 2 times 6.
You see, now you are getting me, may I please have that? So factorizing 12, you are going to say 12 is equal to?
1 times 12.
1 times 12. How else can you factorize 12?
2 times 6.
2 times 6. How else can you factorize 12?
3 times 4.
3 times 4. How else can you factorize 12?
4 times
4 times 3, I will accept that. How else can you factorize it? 6 times 2. Okay, great. How else can you factorize it?
12 times 1.
12 times 1, right? How else can you factorize it?
Or you can say 2 times 3.
Correct. This is still factorizing 12. So to factorize something is to tell the truth about what it is, but you're breaking it down into its factors and bringing in multiplication. That's all. So what we did initially was naming the factors of 12. So to list the factor of 12, that is one question. And sometimes you get those questions, right? Like, what are the factors of 36? You know? Sometimes you get that. So that's what I'm saying. You have to be very careful. Read the question, understand what you're being asked to do. So even here, what we did first was to list the factors of 12. But when I ask you to factorize 12, all that I'm asking you to do is to say 12 is equal, break down 12 into its factors and do the multiplication. Tell the mathematical truth. So that is what factorizing is. Do we understand it with numbers? Okay. So it means that we understand that 12 can be broken down into several ways, right? So now let's skip steps now and go to, maybe not skip a step. For the total's sake, I'll do just one more. 4x plus 2. Okay. Have you been taught factorizing? Not. Okay. Factorizing is just that. You find the factors of this expression. Okay, Estienne, I know you know this one. Tell me what to write.
Isn't it like 2 times 2x?
2
Times 2 times x.
like this.
Yes.
Uh-huh.
Plus 1 times 2.
Mm-hmm. No, don't think about factorizing about how I just taught you. Tell me your normal factor. If you were given this in a test, how would you factorize?
I would say 4 multiplied by x times 2 times.
You'd say 4 multiplied by x
Plus 2
plus 2
is equal to 2 times 2.
is equal to
2 times
2
2 times.
times 2
Multiplied
multiplied by
x.
x plus 2.
That's how I think I don't know. I mean,
Okay, but what you've done here is actually very good, because then it will allow her to see something, right? What is the highest common factor between these two expressions? So you can take that highest common factor and put it outside of the bracket. Okay, so because you're still telling the truth, I don't have to rub this out. So I'm going to put 2 outside, right? So then how do I reduce? The 4 is now 4x is now reduced to what?
2 times
2x, right? And the 2 is now reduced to 1. Do you see that? So what that helps with, little, is that when you are given something like this, you need to understand that this is a times, right? And then you must times this by that, and you must times that by that. Right? Remember we had 12 is equals to, all those things on this side were equal to 12, remember? So now we need to times this out to make sure that what we did is correct. Right? What is 2 times 2x? Speak up, please.
4x.
What is 2 times positive 1?
2.
Positive 2. You see that the same? So we factorized it properly. Okay, so you took an expression and you saw that, listen, you can leave it like this, but this can be written in factors where we have it in simple form of some sort. Do you understand how to factorize expressions? Okay, great stuff. I'm going to jump and maybe leave you behind a little bit, but that's fine. I'm going to go now to... Actually, there's one here that you can do. Yeah, it's fine. We're going to do number 1. Okay, so let's continue. She'll catch us on the way. It's x squared minus xy, correct?
Yes.
What is that? How do you factorize that? Tell me what to write.
X minus x minus x minus x. No, x multiplied by x minus x multiplied by y.
Mm-hmm.
Then you put the bracket
Wait.
in front. You
I
write,
do
you
equal?
write x
Equal to?
equal to x
Mm-hmm.
then you write the bracket then you say x minus xy. No, minus y.
Very good. You're not as confident as I want you to be with this, and I need you to be confident with this. Okay? So, this is the sum that we just did. How to factorize this. Okay? So, I love that you did this middle step, Estienne. That you're going to do this enough times, and then next time you can take out that step. Okay, I love that you went that route. Okay, Rina, what we have here is x squared minus xy. That method that you're using, you can continue with it. I'm just going to teach another method. If you understand it, you can use it, but if you don't like it, stick to your method because it's correct. Okay, so what you need to ask yourself when you're factorizing things where we are plusing and minusing, right? Variables. What is the highest common factor between these two? Okay, then Estienne's method rescues us. Let's break this down into its factors. What are the factors of x squared other than 1?
Factors of x squared.
Okay, we had 12 is equal to 1 times 12 and all that list, right? X squared is equal to what? Other than 1 times x squared and x squared times 1. What is x squared equal to?
X times x.
Yes. So what are the factors of x squared? X. Right? X is a factor of x squared. Okay. So now, what are the factors of xy? X and y are the factors of xy because x times y gives us xy. Do you understand the difference? So here I was asking you, list for me the factors of x squared. It's 1 and x squared. Somebody sleepy today again.
It's because
Because this is easy for you.
I'm writing biology.
Tomorrow. So, list the factors of x squared. 1, right? And the last one is always x squared, correct? What are other factors?
X.
That's it. Okay. List the factors of xy. We always start with 1, right? Uh-huh. X is a factor of xy. Y is a factor of xy. And then xy is a factor of xy. Do you remember? This is the same as when we were doing it with 12. Let's say 6 because 6 is nice and short. Is this similar? Do you see that this is the same thing that we did with numbers? Because with 6 it was 1, it was 2, it was 3, then it was 6. Because you must remember that 6 is 2 times 3. So we had 1 and we had 6. We had 2 as a factor, we had 3 as a factor. Do you get it? So then, here are the factors of x squared and the factors of xy. What is the highest common factor between these two expressions, these two terms? Just like I would ask you highest common factors between 12 and 8, what is the highest common factors between these two variables? What are the common factors? The common factors between these two are 1, right? And x. X squared is not a factor of this. Y is not a factor of x squared. So what is the highest common factor?
X.
X. Do you see? So then you take the highest common factor of that, these two, you put it outside, right? And then how you need to reduce the remaining terms. So x squared would be reduced to x squared. I've just divided this with the highest common factor.
X. So it would be y.
X squared will be reduced to
X.
x. Then I bring down the negative. Xy will be reduced to remember what we do when we reduce things, when we're dealing with the highest common factor and we are reducing things, we always take that number and divide it by the highest common factor. So you have xy divided by x. It's y because x cancels x. Okay? Or if you can think of it in terms of exponent laws. This is exponent 1, this is exponent 1, right? The bases are the same. You keep the base and you minus the exponent of the denominator, we minus it by the exponent of the numerator, which is 1 minus 1, correct? And that gives us x to the power 0, y. Anything exponent 0 is equal to 1. So then this is 1 times y, which is the same as y. Okay, so this is a long way of remembering y. If you say, if you want to reduce xy by dividing it by x, what you get is the x actually cancel each other, and what you get is y. Do you understand? I know you understand, Mr. Sleepyhead. Should I switch off?
Yes,
No.
please.
I think I will just make you.
I think so too. I think so too. I put it on low. Okay. Do you understand factorizing? Do you have a better understanding of what factorizing is? I know you could do this, but I want you to be confident in it. Okay? Now, do you understand what we just did here? It's like highest common factor reducing things. We are reducing. We find the highest common factor, we put it outside the bracket, and then we reduce the original. We reduce the original terms into a new term. Okay, or expressions into new expressions. Okay. So next one. What's the next one, Estienne?
It is 2 bracket x plus y.
Plus y.
Close the bracket. And then it's minus t.
Minus 3.
T. For that.
Minus?
For t. Not the
Minus t. Yeah.
And in bracket,
Yeah.
x plus y. Close the
Excellent.
bracket.
Okay. So now, what is the highest common factor between these expressions? Huh? Is x acting as a factor between it and y?
No, 1.
One is a common factor, but it's not the highest common factor. This is an expression. This is an expression. Okay. So I'm going to give you another example. Ne? 2z minus tz. What is the highest common factor here? Z. But look at what I just did. What is the highest common factor here?
Y and X. Oh,
X plus y. This bracket is our highest common factor. Do you see? Do you see? And if we were here, what would we do? We would say z outside, right? Bracket, what would be, how would we reduce this?
2 1 times 2.
So this would be 2, right?
Yes.
And this one would be minus, we bring down the sign, minus what?
T.
Right? Because we're going to say tz divide by z and it will get t. Do you see? So in the same way, and this is what I want you to be careful of. When you have expressions as the highest common factor, you might feel, what do you mean factorize? In your head or with a pencil, just pretend that this is A and also this is A, for example, or any letter. I used Z in this case. Okay, pretend, replace this, when you get complicated things sometimes, replace them with simple stuff and see if you know how to solve them. And if you know how to solve it with simple stuff, you must follow the same steps that you used with the simple stuff. Did you see these steps were easy, right?
Yes.
So then here you follow the same steps. Okay, so let's follow those same steps. Let's see. Tell me what to write. I'm going to write it again. It's 2x plus y minus t x plus y. Okay, so what did we do? We asked ourselves what is the highest common factor between these two. We identified z as a highest common factor, right? And then we put it outside outside of the bracket. But in this case, what is our highest common factor then? X plus y. So tell me what to write. X plus y. Bracket. Open or close bracket? Open. What did we do?
2 subtracted by t.
Okay, halfway correct. What are we supposed to do? Estienne?
Supposed to say x plus y. No, I don't see this.
We're supposed to keep it in brackets.
Why?
Oh, because it's a whole.
It's a whole expression, you know. When we leave it like this, we are saying x is the one that we must multiply the y. If we leave it this way, what we are saying is y is the one that we must multiply, but this is just adding. But if you make both of them brackets, it tells a different story. When you make two of them brackets, you are saying this times that, that times that. You're also saying this times that, that times that, which is the truth. Okay? Do you see how to do this?
Yes.
Simple enough? But you see that it's very easy to get it wrong. As simple as it is. If you don't treat it the same way you treat this, then you're going to get it wrong. And look, what you didn't know, even though here we said z, remember z here includes the whole expression, including the brackets. So don't leave out the brackets. Okay, you get it, right? Next, factorizing. So be very careful of these types of they are most likely going to be there in your exam. Okay?